Welcome back, Math 8 scholars. Okay, so back at it again. The second type of transformation that we're going to talk today about are called reflections, and it is exactly what it sounds like. So by now, I hope that we know that there are 4 types of transformations. We just took a look at translations, reflections, there's going to be rotations, and dilations. So that was in your tree map. But a reflection is a type of transformation. It's basically a flip or a mirror of an object, so of a shape over a line of reflection, and it creates this mirror image of a shape. And we call that image congruent because it has the same size, the same shape, same angles, okay? Nothing about it change. So congruent, again, means, if you want to shorthand it, equal size and shape. So let me give you an example of that. Again, I'm using what resources I have at home, so we're not judging. I have this really cool Kirby thing that I found in my son's room. Again, the hand again. Okay, and I'm gonna cheat. I have a mirror, okay? And when I hold this mirror up and I use the mirror literally as the line of reflection, we can see how things kind of become opposite. They become backwards. The Y seemed like it used to be on the right hand side. It's now on the left in the image reflection. The K was on the left, but now it's on the right. So again, this is an example of a reflection. Also, I don't have my document camera with me, so I am using my camera on top of a seaweed box taped to a paper cutter. Again, we're not judging. Okay, let's see. We got this little dude that I found in my son's room, Homer Simpson. Again, he's not as easy to see in the reflection, but everything is backwards in theory to him, okay? So think of yourself holding up a mirror for reflections. Right, awesome. So getting back to this, I went ahead and I pre-annotated that we have our pre-images and our images, meaning before and then the after. And the only reason why I know that is because this one didn't have that prime tick mark and this one did. And same with these examples as well. Okay. If you want to take a moment and pause this, that's fine, to write down the rules. And I'm going to prove those rules for you in just a moment. Let me get back seated here. So anytime we reflect something over the x-axis, what we're going to see, you don't have to trust me yet, but we're going to see is if this used to be the coordinate, the x values will remain the same, but then the y values become the opposite. So remember, in math, negative implies opposite. Okay. When we see that we reflect something over the y-axis, we're going to see that the x coordinate become the opposite in value, but the y coordinates stay the same. So you don't have to trust me or even understand what that is just yet. We'll see that momentarily. Okay. So up with our first example of the day for reflections. It's very similar to translation. So we're just going to see which of these is a reflection. Once again, I have to physically interact with my transformations. That's just how my brain works. So I went ahead and I took my little cheat sheet. I already wrote and traced down that arrow here. I know that a reflection is a flip, a mirror. So I'm going to go ahead and take this and I'm going to flip so my brain can kind of understand what I should be looking for. This first example does not appear to be a reflection because it's not facing the way it should, okay? This second example is a reflection. Do you see how it matches with that flip? Again, if I wanted to cheat further, I could use my handy dandy mirror. This is the image I should be seeing, right? They're like pointing at each other, but that's not what I see in reality. Again, this is what I should be seeing in theory. And yeah, I see that. Now, this line of reflection should have been shifted over more. I think that was an error with the notes. So this line should be directly in the middle, okay? But we see here that the second image, or image number 2, is an example of a reflection because the pre-image mirrors or it flips. So the pre-image, I'll just call it flips. And it's congruent. You're going to be so tired of me saying this word, congruent. Same size, same shape, same angles. It's a big part of this unit. Okay, once again, let's see if we can catch which one of these reflects. Again, did I cheat? I sure did. So I have my reflection or my pre-image traced, ready to go. I know that a reflection is a flip. Okay, I'm not turning this. It has the same I'm not turning this like a translation. Oh my gosh, turning it like a rotation. I'm not sliding it like a translation. I'm just gonna flip it. So I'm flipping it. And that is not a reflection. Okay. This is not a reflection. This is not a reflection. Winner, winner. That example right there, B, does look like it is a reflection. Again, I could also use a mirror and determine that that is a reflection as well. Okay, so we're going to go with example B is an example or represents a reflection because it shows a flip or a mirrored image. All right, cool. Now comes the tricky part. Now that we know what it should look like, what a reflection should look like, let's do one. And sometimes doing one and making one is where it's a little bit more challenging. Okay, third example, just like our previous foldable, we're going to go ahead and take MATH, math, and then we're going to go ahead and figure out which coordinates M prime, A prime, T prime, and H prime should be. And as I'm annotating here, it says that they want me to take that trapezoid math and reflect it over the y-axis. So I'm going to go ahead and do that. Ooh, excuse me. So if I take my little cheating mirror here, oops, wrong way. Okay, this is what it should look like when I'm done. So just imagine everything is opposite. And again, over the y-axis literally means the line of reflection, or think of that mirror. The mirror is sitting on the y-axis. So this is what my answer should look like. Now it's just a matter of creating that on our paper. If you can see this the way I see it, notice how M is 1 unit away from the y-axis. M prime should be 1 unit away. A is 1, 2, 3 units away from the y-axis. So A prime needs to be 3 units away as well. So here we go. Let's see if we can make that a reality here. Again, if this was 1 jump away, I'm going to go ahead and have it be 1 jump away. 3, 1, 2, 3. This is where A prime should land. H was 1 unit away, so let's go ahead and do that in the opposite direction. T was 5 units away, so let's go the opposite direction. 1, 2, 3, 4, 5. Again, you're going to know in this unit if you have it correct, because when you connect the vertices, it should still look like it should still look like the same size, same shape, but it has flipped. So more or less that looks fine. And I'll go ahead and put my coordinates here. So notice how this used to be a positive 1, but now it's a negative 1 for M. The y coordinate has not changed. It used to be a positive 3 for X. Now it's a negative 3. The y coordinate has not changed. T used to be a positive 5 for X. Now it's a negative 5. The y coordinate of 2 has not changed. H was 1. It's now negative 1. The y value is 2. It hasn't changed. So remember I spit the rules at you at the beginning. It didn't really mean anything at the time, but when we reflect over the y-axis, notice how the y coordinates stay the same, but the x coordinates became the opposite. So you don't have to memorize that, but that's kind of like a aha moment there if you did want to just skip and go straight to the coordinates. Again, we see here that the y coordinate, or excuse me, the x coordinate is opposite. And the y coordinate is, or I guess the y coordinates are, Let's pretend like this is the same. Grammar. Okay, I'll let you fully complete example 4 on your own. Again, it's asking us to reflect it over the x-axis. So whereas last time I held the mirror up vertically on the y-axis, now I have to hold it up horizontally on the x-axis. And this is my line of reflection right here, okay? That was line of reflection for y-axis. So when I hold up my mirror, I'm going to be holding it up that way, but I'm not going to show you the answer, okay? So go ahead and give this one a try. You should have a triangle that has kind of flipped in this general direction, and see what the new coordinates are. And based on what you're seeing here, see if you can fill in these blanks. What's going on with the x coordinates? Are they the same? Are they different? What's going on with the y coordinate as well? Okay, I hope you guys have a good rest of your day. Take care and stay out of trouble.